Hi, this is Jeff Spence, and this is part 2 of our Chapter 12 discussion answers, so let's keep it going. So number 6, it says, use the following data set to answer each part. Give the mean, median, and mode. Well, the mean is going to be the sum of all the data values divided by the number of data values that we have. So let me pause this for a sec. Alright, so the sum of all the values is 120, and there are 15 values. When you divide that, you get a mean of 8. The median is the middle data value. So if you list these all in order, so 5, 5, 6, 6, 6, 6, 6, 8, 8, 8, 8, 8, 10, 10, 20. And when we get to the middle here, there's 15 data values. It should be 8 because 8 is in the middle. The median is 8. Then when I cross off and get to the middle, it's 8. And then the mode is the most frequent repeating data value. Well, that's a tie with 6 and 8. The range would be the largest data value, which is 20, minus the smallest data value, which is 5, so the range is 15. And then give the standard deviation. Let me copy this table here. And the data items are 5, 6, 8, 10, 20. There's nothing there. Okay. And then the mean is 8. So 5 minus 8 is negative 3. 6 minus 8 is negative 2. 8 minus 8 is 0. 10 minus 8 is 2. And 20 minus 8 is 12. Then when I square these values, alright, so when I square negative 3, I get 9. But there are 2 5s, so I multiply that by 2, I get 18. And when I square negative 2, I get 4, but there are 5 of those, so that's 20. And then if I square 0, I get 0, and there are 5 of those, so I get 0. There are, when I square 2, I get 4, and there are 2 of those, 2 tens, so I get 8. And if I square 12, I get 144, and there's only 1 of those. So then the sum is 190, and then when I take that 190 and divide by the number of data values, which is 15, so, or sorry, divide by the number of data values minus 1, so I take 190 divided by 14, and I get 13.57. Then I take the square root of that answer, so square root of 13.57, and I get 3.68. So standard deviation is 3.68. It says, number 7, it says, which data set, problem 5 or 6, had more dispersion or spread? Well, dispersion or spread is measured by the standard deviation and range. So the standard deviation is 3.68 and the range is 15 for 6. And the standard deviation is 8.78 and the range is 32 for 5. So 5 has a larger spread because, problem number 5, because the range and standard deviation are larger. Those measure spreads. It says, tell which of the following distribution would have the least variation. Well, this is spread, and so really when we're looking at these weights, I think the most specific group would have the least spread. So that answer is going to be C, weights of 20-year-old women. It says, this one says, which one would have the most variation? I don't know what I'm doing here. I don't know what happened there. Oh dear. Okay. Which of the following would have the most variation? Scores on a test where everybody got a perfect score, that would have a 0 variation. Scores in a test which had half of the students in C and half got half failed. Scores in a test with half got an A and half got a B, and scores on a test when half got an A and half failed. It's going to be D because we're looking for the largest variation, and the largest variation between A's and fails is the greatest variation between all these B's and C's. So then it says tell which of the following distributions would have the least variation. So once again, we're looking for the most specific group, and that's going to be the Olympic sprinters because they all have to be pretty damn close to be in the Olympics. College seniors, adults, and male college seniors would all have pretty wide-ranging times because not everybody's a sprinter. Number 11, it says a pizza shop did statistics on the two delivery drivers, Amanda and Bethany. They had each driver deliver to the same general location multiple times over a month and record the driver's time to complete the delivery. So basically, they deliver the same route, they looked at the same number of times, and they both had an average of 25 minutes. But Amanda had a standard deviation of 3.8 minutes, while Bethany had a standard deviation of 10.6 minutes. If you had to keep one of the two delivery drivers, who would you pick and why? I would pick Amanda because since her standard deviation is 3.8 minutes, that means most of her times are within 3.8 minutes of 25 minutes, and that makes her more consistent. While I can't necessarily say that Amanda or Bethany is faster, Bethany probably has the fastest time, but she probably also has the slowest time because she has a wider variation in her times. So reliability is good in many things, especially when delivering pizzas, so I'm going to hire Amanda because she's more consistent. Number 12, it says, suppose I gave the class a test and everybody passed. The mean was 73.5 and the median was 72. This is when I calculated, but I calculated the mean and the median before I included a student who did not show up to test and got a 0, so I kind of kept them out of the calculations. It said, how would that student score affect the mean and the median for the class if we included the 0 in the data set? Well, if I include the 0 in the data set, the mean will go down, not necessarily significantly, but more. When I add a 0 to the sum and then divide by one more value, it should bring the mean down because I didn't add anything in the numerator, but I'm dividing by another number. So the mean would go down into the 60s, I would bet. However, the median would pretty much be the same as 72. It might go down a little bit, but not as much. Median may go down, but not much, because the median is a position thing. So now that I have this 0 in the list, and now all the scores are like 60 and above, etc., and I have like the 99 at the top, when I cross off the high score 99 with the 0, I still end up in the middle, which is about at 70 something. So the mean, we like to say, in statistics we say the mean is sensitive to values like this, but the median is not. Alright, number 13, it says the mean weight of newborn infants is 7 pounds and the standard deviation is 8.8 pounds. Draw a normal distribution to answer the following questions. So there's the 68, 95, 99.7 rule, which you're supposed to know is that 68% of the data is within 1 standard deviation of the mean, 95 within 2, and 99.7% of the population is within 3. So when it asks for 68% is within what 2 weights, that's 1 standard deviation below to 1 standard deviation above. So 1 standard deviation below would be 6.2 pounds. So 1 standard deviation above would be 7.8 pounds. It says give the percentage of infants that have a weight between 4.6 and 9.4 pounds. Well, 4.6 and 9.4 are 3 standard deviations below and above. So this is going to be the 99.7% is within 3 standard deviations below to 3 above. This one, the next one, is 5.4 and 8.6 are 2 standard deviations below and above. So that's going to be 95% based on the 68, 95, 99.7 rule. Then D, it says give the percentage of infants that have a weight above 9.4 pounds. Well, 9.4 pounds is 3 standard deviations above the mean. 3 standard deviations above the mean. So, and we know that 99.7% is within 9.4 and 4.6. So we want to know the percentage above 9.4. Well, 99.7% isn't all of it, so if you do 100 minus 99.7, that gives you 0.3%. And that's the percentage that is either below 4.6 or above 9.4. And the bell curve is symmetric, so if we just want the percent above 9.4 and not above or below, then we just divide it by 2 and we get 0.15%. Same idea here with E. It says give the percentage of infants that have a weight below 5.4 pounds. Well, 5.4 pounds is 2 standard deviations below the mean, and we know that 95% is within 2 standard deviations. So 195, 100 minus 95, 5% is outside of 2 standard deviations, but we just want the lower half, so we take that and divide it by 2, and we get 2.5% that are below 5.4 pounds. Next one, it says females' heights in North America are approximately normal, blah, 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 blah. It says who is relatively taller, a 76-inch man or 78-inch or 68-inch woman. So the z-score formula is z equals the mean, or sorry, no, the value minus the mean divided by the standard deviation. And that lets us know how many standard deviations above or below the mean a person is. So for the man has a z-score of, let's see here, I'm going to write this. He's 76 inches tall, but the average man is 70 inches tall, and the standard deviation for men is 4 inches. So 6 divided by 4 is 6 divided by 4 is 1.5. So I did the 76 minus 70 first, and then divided by 4, 1.5. So the man is 1.5 standard deviations above the mean for men. The woman, her z-score is, she is 68 inches, so she's taller than average too. She's 4 inches taller than the average, but the standard deviation is for women is 3 inches. So when you take 4 inches divided by 3, you get 1.33 standard deviations above the mean. So the man is taller relatively to his sex or his gender, because he's 1.5 standard deviations above the mean, and the woman's only 1.33 standard deviations above the mean. Next one, it says same kind of idea here for the ACT and the SAT. So let's look at the ACT. The z-score there is, you got a 27 on the ACT, and the mean was 25, and you divide that by 2.1, and you get 0.95. The SAT, when you do the z-score there, you got a 560, and you divide or subtract 500. Divided by the standard deviation of 100, and that's 0.6. So the ACT is the test that you did better on, because you scored higher relative to the mean versus the SAT. So that's it. We'll see you next time. Good luck on the exam.